Hi students, today we'll solve a problem based upon the arrangement of the capacitors. So in a particular type of arrangement of capacitors, we have to find out the potential difference between any 2 points. So let us go through this question. The question is that determine the potential difference VA minus VB of the circuit shown below. Under what condition is it equal to 0? So in this circuit you can see we have two branches, this one and this one, and the points, this is VA and this is your VB. So we need to find out VA minus VB. So here you can see these two branches, so that means both are in parallel. So in parallel means the potential difference will remain same. And you know, in series when capacitors are connected, then the charge will remain same, but the potential gets divided. Similarly, parallel connections, the potential will remain same. So suppose we are writing this one as, suppose this is x dash branch and this is your y and y dash branch. So the potential difference across x dash branch and y dash branch will be same because they are connected in parallel. But in a branch, suppose x dash, we have two capacitors, that is C1 and C2. So we can tell that the potential difference across C1 and potential difference across C2 will be different. So the total potential across this x dash arm Bx x dash will be equal to, this will be the potential difference, that is V1 plus V2. So for V1 we can write, suppose the charge in this branch is Q1 and in this branch the charge is Q2. So here we can write, for V1 we can write Q1 by C1. Similarly for V2 we can write Q1 by C2. So now you can see that we can take common Q1. So this will be 1 by C1 plus 1 by C2. So by simplifying we will be getting this one as Q1. This will be C1 plus C2 upon C1 C2, right? So for this case, suppose this we are considering as V. So here your Q1 will be equal to, this is V into, that will be C1 C2 upon C1 plus C2. Similarly for the second branch, that is y dash, let the potential difference, this will be y dash, and you know this will be equal to Vx x dash because they are in parallel connection. So the total potential across this y and y dash will be your V3 plus V4. So for V3 I can write, this will be Q2 upon C3 plus this will be Q2 upon C4. So if I take common, so this will be 1 by C3 plus 1 by C4. So this will be equal to Q2. Now we'll get, this will be C3 plus C4 upon C3 C4. So similarly we can get here, this Q2 will be equal to V into C3 C4 upon C3 plus C4, right? So now we get the value of charge Q2, which is across the branch y dash. Similarly Q1 across the branch x dash. So now we need to find out VA minus VB. So directly we cannot find out VA minus VB. So for VA we will find out VQ minus VA, and for VB we can find out VQ minus VB, so that by subtracting we will be getting VA minus VB. Now you can see here, so for VA minus VB we can simplify. This VA minus VB can be written as VQ minus VB minus, this will be VQ minus VA. So this will be equal to your VQ minus VB. So this is your V4. This is your V4. Similarly, this is VQ minus VA. This will be your V2. So here I can write V is equal to Q by C, you know. So for V4, I can write this will be Q2 by C4. Similarly, for V2, I can write this one as Q1 upon C2. Right? So here you put the value of Q2 from this and Q1 from this. Then we'll find this value will come as V into C2, that is C4, that is C2 C3 minus C1 C4 upon C1 plus C2 and C3 plus C4. So this is the required potential difference. So I think you all got this. Now for this question, again in the question it is given here VA minus VB, under what condition it is equal to 0. So if we are taking VA minus VB 0, so that means V into this will be 0. So this is cross multiplication, then we will get your C2 C3 minus C1 C4 will be 0. So that is condition for 0. So we write this VA is equal to VB, that is VA minus VB equals to 0. So by using this formula for VA minus VB, we will find C2, that is C2 C3 minus C1 C2 equals to 0. So implies that we will get C2 C3 equals to C1 C4. Similarly, we can get C1 by C2 equals to, this will be your C3, that is C1 C2. So we'll get C2 C3 minus C1 C4. So C1 by C2 will be equal to C3 by C4. So the condition, you can say here the condition for the potential difference to be 0 across the points A and B will be C1 by C2 is equal to C3 by C4. So this, you know, this is as a result of for a balanced Wheatstone bridge. So I think this question is clear to you. Thank you.